Hello, calculus students. Welcome to another online lesson. We have completed our unit on probability, and so we are now starting a new unit on statistics. And today we'll be talking about different types of variables, specifically discrete, continuous, and categorical. We'll talk about how we can arrange these variables or this data using column graphs, histograms, and frequency tables. And we will review mean, median, and mode. So to start off with, our first learning intention talked about variables. We've talked about variables in algebra class before. A variable is something that can vary. That would be the root of the word. We'd often use like an x to represent some number, and we would often define that based on how it was in an equation. It could be any number, but that value becomes more specific when we give other information, like x plus 2 equals 5. Suddenly now we've essentially defined what that variable is. Categorical, quantitative, statistical variables are a little bit different. They're like an algebraic variable in the sense that we often use x, and it's also something that represents multiple things. But we want to think of these more like a label. So when we have a categorical variable, it's something that describes a particular quality or characteristic. So it's a description. Such as the color of shirt worn by a student. Now, in a particular class, each student might have a different color shirt on, or maybe some have a blue and some have red and some have green or white or whatever the case is, but it can vary. And because we have different answers depending on who we look at, that's why we call this a variable. But again, the categorical variable describes that characteristic, color, perhaps style, perhaps reasons, explanations, anything involving words for the most part. A quantitative variable, it has numerical values. So that could be things like amounts, like the number of students Mr. Peacock has in a class. That changes depending on which class you look at. Or when we do our breakfast party counts and the students go around to different classes, they will have a different number depending on which class they look at. Some are very big and they might have full attendance. Others are smaller, either because they were a smaller class or maybe they have worse attendance in those class. When it comes to quantitative, this is a math class, so the numeric variables we break into two different categories. Discrete variables. These are usually counting numbers, often whole numbers. They don't have to be whole numbers, but they often are the result of counting, and they don't include every possible value, such as when we're talking about a number line. If we have the number 1, 2, and 3, if I was counting students, I would utilize the number 1, I would utilize the number 2, I would utilize the number 3, but I wouldn't utilize numbers in between there like 1.5 or pi, things like that. So discrete, it doesn't include all the values. Usually it's whole numbers, and it's always or almost always a result of counting. Continuous variables, these are measurements. So when you make a measurement, we are talking about continuous, because measurements can be anything on the number line. You can have, a child that weighs, 3 kilograms, but you can also have 2.75 kilograms or 2.5 or 2.419873 or whatever the case is. Any value on a number line is possible. And again, we usually get those from measurements: time, weight, even height, things like that. Variables should be specific. They shouldn't just say things like student or things like size. It should be, specific, things like the color of shirt worn by a student in Mr. Peacock's 1B math class. That's a specific variable. It's a good variable. No pronouns used, things like that. Again, think about what you would do to label something like on an X and Y axes. Those are the kinds of things that we'd be writing for our variables. So I've got a few examples here. Classify the following variables as categorical, quantitative, discrete, or quantitative continuous, and explain why. So the amount of rainfall in a week. Well, when we try to figure out how much rain we had, we usually are not counting drops. We're making a measurement of sorts. Usually they'll do it in inches. They put a bucket down and see how many inches got filled up. So that's a measurement. And again, you can make a measurement that's, decimals, infinite sorts of values. And so this would definitely be quantitative because it's a number, and it would definitely be continuous because it is measured. Gender of state legislators. Well, think about different values that we could have for this. Gender of state legislators, you could have male or female state legislators. Therefore, we are talking about categorical. Fall into one of two categories. The items sold at the school snack shack. Now, a lot of people might think this is discrete. You can count up how many things were sold, but it didn't say the number of items sold. If I were to actually say, if somebody were to ask me, what are the items that are sold at the snack shack? I know that's changing these days, maybe towards a healthier variety, but in the past we've had things like Cheetos, chips, soda. So those are categories. So this is a categorical variable. Again, if it said the number of items sold at the snack shack yesterday, that would be quantitative discrete because I could count up how many things were sold. But in this case, it's categorical. All right, number 4, the number of senior citizens in the United States. Well, it already says numbers, so I know it's quantitative. And you can't have a part of a senior citizen. You would count each and every one of them, and it's a counting number for sure. So for a lot of reasons, this is discrete. Again, counting being the main reason. And then finally, the fastest times at the cross-country meet. Well, time is a measurement. Time we use numbers, so it is quantitative continuous. All right. Moving on to our next learning intention. Column graphs versus histograms. One way we can arrange discrete and continuous quantitative statistical data is using column graphs, or as we often call them, bar graphs. So there's two main types of bar graphs. You got your regular column graph, and then you have a histogram. Now, I can probably find many examples that don't follow these rules, even on IB tests, but in general, both of these should have a horizontal and vertical axes. The vertical axis for both of these is always going to represent frequency. So it tells us how many we had. On the horizontal axis, we're always talking about our data. For a histogram, you're labeling each one of these, so I could even do categorical data here, like I could talk about colors of cars in the parking lot, and maybe these were blue cars here, and these were black cars, and these were red cars, and so on and so forth, and I could count up how many there were, aka the frequency, and I would have a different value for each one of those differing heights, which would tell the amount of the categories that we had. I could do that also for discrete data. I could have each one of those bars represent a different number, such as the number of pets a family has, maybe 0, and so I count up how many people had 0 pets, and then how many people had 1 pet, and how many people had 2 pets, and so on and so forth, and there'd be different frequencies for each of those differing variables. In both cases, the column width should be the same, so each one of these columns should have the same length as the one right next to it. Histograms, though, are used for continuous data, ranges of data. Oh, and I apologize, I was writing all this stuff here on the histogram that I should have been writing on the discrete data stuff. So when I was doing the colors, like, the black and the red and those sorts of things, they should have been here on a regular column graph. The histogram, on the other hand, has no gaps between the columns, and we use that for continuous graph or continuous data because we can actually have a number line. We might have a group from 0 to 10, and then from 10 to 20, and 20 to 30, and 30 to 40, and so on and so forth. So maybe these would be class sizes, and so we could count up all the classes that had values between 0 and 10, and I would have that frequency right there, and then go through all the classes and see how many had between 10 and 20 students, and I would have that frequency there, and then between 20 and 30 students, so on and so forth. So it actually uses like a number line, and your values don't go centered on the bars. they have an interval, a beginning and an ending of each one of those intervals. And we often call that interval a class. So each one of those groups is a class. So again, main differences, column graphs can be used for discrete or categorical data. Histograms should be used for continuous data. Column graphs generally have gaps in between. Each bar represents one specific piece of data. Histograms, the bars touch each other. The x-axis should be like a number line, and each bar represents an interval of data, or a range, or a class, or a group. As we just mentioned, each group is called a class. So if I say, how big is the class, you would say, how big is the interval that we had from where one bar started to where it finished. Maybe you go by tens, maybe you go by fives, maybe just one, maybe even 0.5 if your data is very small and close together. The size of the group is called that class interval. Again, interval refers to the number that you start on to the one that you finish. The class interval, again, is how big is each class. And they should be equal length. You'll find occasions where they're not, but a good class interval should be the same throughout the graph. So I'm going to create a histogram for this data. I don't have any graph paper here on the slide, but I will do my best to make it as neat as possible. And I start with an x and a y axes. I don't have a lot of room here on my vertical axes, but if I look at my frequencies, I never get above 9 here. That's my highest value. So I'll just go up to 10, and I can cut that in half to be 5, and then break that up into 5 equal parts, or the best of my ability. And there I've got my frequency. So normally our graphs will only have one variable, and so our y-axis is the frequency of that variable. And then for my x-axis, that's my actual data, my actual variable, which is height in millimeters. And that's not a great variable because height of what? It's not as specific as I'd like it to be, but for this particular data, we will work with it. Oftentimes, you'll want to put a break on your x-axis just so that you don't have your data smack dab up against the vertical axis or the y-axis. You don't have to do that. Other times we might start not on 0, but start on like 100, and you might want to put that break so that you don't have to have all this dead space over here. You can only do breaks, though, on your horizontal axis, never on your vertical, because that would affect your bar heights. So I did a little break, and I'm going to start my 0 right there. And now it's just a number line. So I've got 0, 10, 20, 30, all the way up to 80. Trying to make these as equal as possible so that all my classes are the same class interval of 10, and that's visually represented as well. All right, so now I go from 0 all the way up until the next class, which starts at 10. So 0 all the way to 9.9 repeating, essentially 10. I have a frequency of 3. So I start my bar at the 0, which is the beginning of the class interval. I go over and come back down right at the 10. Now my next one goes from 10 to 20, and there are 6 pieces of data, or a frequency of 6 in there. Sorry, my bar got a little carried away from me. And you'll notice, once again, my bars touch because where one starts, or where one ends, that's where the next one picks up. And then I go from 20 to 30, and there were 5 there. So I can sort of cheat and just steal the right side of that bar. And then from 20 to 30, I just did, I'm sorry. Did I miss one? Yep, no, that's good. And then we've got, might actually help me if I say up till 10, up till 20, up till 30, 40, 50, 60, 70, 80, and going all the way to 90, which I did not have. There we go. All right, so from 20 to 30, we said was 5. From 30 to 40 is going to be 8. So we should go up about that high. It's easier if we have a grid or a graph. And then 40 to 50 is 9. So all the way up to the second highest value. And then from 50 to 60 is 7. So up here. And from 60 to 70 is 5. 70 to 80 is 6. And finally 80 to 90, we had 2. And that is a histogram. We've got a label on the x and vertical axes. If you want to title this, I know teachers will encourage titles, and that's really just going to be your variable again, because we have no other data to go with. So height in, in millimeters. And that's a quick and dirty example of a histogram. We can actually answer a lot of questions now about this data using the histogram. We, for example, know what our modal class is. Introduce that word, modal class. You may have not heard those words used together before, but if we're trying to figure out what it is, we know that class means group or interval, and we have a bunch of those. Each one's represented by a bar. Modal, what's the root of that? Mode we'll talk about on the next slide, but mode's one of our uses for finding the central tendency or the average of data, and it's the one that occurs the most, sort of an alliteration thing there. So mode is most, and which one occurred the most? That would be this class right here from 40 to 50. You can study things like the sort of distribution or the skew of our data. We'll notice that we have sort of a bell-shaped curve happening here, some fluctuations, but it's pretty normal distributed data. If it was skewed, we would have one of these sort of lines sort of extend off. That would be a positive skew. Skew means stretch. So anyway, that's a histogram, and we'll talk more about those in the future. Mean, median, and mode. We've seen these terms many times before, all the way back in middle school. Mean, we take the sum of our data, and then we divide by the number of terms that we have. So if we had 3 numbers, 2, 4, and 8, I would take the sum of those, and again, I use sigma notation there. Sum means add up. So I would add up the 2 plus the 4 plus the 8, and then divide by how many numbers I had, which would be 3. So 2 plus 4 plus 8 gets me up to 14, and so my mean would be 14/3, or some decimal approximation of that. Median, we have to list all of our numbers in ascending order, and it's the middle number after listing all of your numbers in ascending order. So for example, I'll just do a very quick one. If I had numbers like, well, I could use those same values there, 2, 4, and 8. The median is the one in the middle, the 4. Now, if we have more numbers or an even amount, for example, I had 1, 3, 4, and 7. Of these 4 numbers, there's no actual middle term, but the 2 that are closest to the middle, the 3rd and the 4th one, I could average those together using mean, and I would have a mean value of 3.5. I'm sorry, a median value of 3.5. Then finally we get to mode. Mode is the one that occurs the most. Now, in most of our data that we've looked at in middle school and early high school, you'd have a list of numbers, and the one that repeats the most is the mode. But you don't have to do that if we have a frequency table, or like we saw on the last slide, a histogram or a column graph, because you just look for the one with the highest frequency. So it's the most, it has the highest frequency. It is possible to have more than one mode if the highest frequency occurs multiple times, meaning the highest bar is tied with one other one or 2 other ones, then you can have 2 or 3 modes. The mode is always the data, though, not the frequency. It's the data that goes with the highest frequency. And it's also possible to have no mode if no numbers repeat or they all repeat the same amount of times. We're going to finish with this old school list of data. No frequency table involved here. Given the following data with a mean of 8. So our mean is 8. So I'm asked to find n. I already know the answer to a problem. The mean is 8. How do I find mean? Well, I add up all the numbers. 5 plus 11 plus 12 plus 16 plus 3 plus 2 plus 5 plus 18 plus 1 plus 2 plus 3 plus 8 plus 9 plus n. Just barely ran out of room there. And I divide that by how many we have, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And if you bear with me, I'm going to add these all up in my calculator. And I get 95. So I have 95 over, I'm sorry, plus n over 14 equals 8. We're trying to get our variable alone. Two numbers keeping it from being alone. I'm first going to clear out that denominator by multiplying both sides by 14. And 8 times 14 gives me 112. So 112 equals 95 plus n. Subtract 95 from both sides. And I get n is equal to 17. All right, on to the next one, which says give the mode. Well, it's whichever one occurs the most. We have to find the median still, and it's often easy to find the mode if you put them in order, because then any numbers that occur multiple times would be next to each other. The way I'll do that is I'll often just rewrite them, crossing off the numbers from least to greatest. I see 1, 1. I see a couple 2s. There's a 3, another 3. If I miss any of them by crossing them off, I know that I'll find them at the end. Got a couple 5s here. No 6s, no 7s. I've got an 8 and a 9, an 11 and a 12, and then 16, 17, 18. I tried to be careful to cross things off. I'm double checking, but I'm also going to count. I know there were 14 digits. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So that all checks out. Now we look for ones that repeat. I see that the 2's repeated, the 3's repeated, the 5's repeated, no other numbers repeated, and they all repeated exactly 2 times. So we have 3 modes, 2, 3, and 5. The median, I have 14 digits. And so it would be between the 7th and the 8th one. 1, 2, 3, 4, 5, 6, 7. So in between 5 and 8. If I add those together and divide by 2, I'm left with 6.5. Again, there are an even number of terms, 14 numbers, so there'll be no actual odd number in the middle. But you can also do it this old school cross-off way, but I don't work that way. And then we just take those middle 2 numbers, 5 and 8, and average them together. All right, so a lot of stuff there, but most of it is review. So I have a handful of problems for you guys to look at on page 504 and 510 to practice those mostly old skills so that we can move forward in our statistics unit.